That's it for additional functions, especially string functions. Let's go into loops. So what loops do is they will let a variable range from some starting value to an ending value and variations on that. So let me give you a little example, and then we'll talk about some additional variations on this. So here's I'm going to make a brand new data set. Let's call it temp, and I'm going to run a loop. So the loop is this: do I equals 1 to 10 by 2. So what that means is we're going to let the variable I range from the value 1 to the value 10, and we're going to increment it by 2 each time. Okay, so we're going to do this loop, and then the output statement is something I've not talked to you about yet. What output does is it tells SAS to output a record. Now, whenever you have a do loop, you have to end that do loop with an end statement, otherwise SAS complains. So whatever is between the do and the end is going to get executed for each value of I. So let's see what we get. So I is initialized to 1, and then we output it. So that's that first record. Now, this is by steps of 2. So 1 plus 2 equals 3. So I next takes the value 3, and that gets kicked out. Increment it by 2. Well, 3 plus 2 is 5. That gets outputted. Then we have what? 5 plus 2 is 7. 7 plus 2 is 9. And now let's pay careful attention to what happens next. After 9, what happens is that I gets incremented by 2, which goes up to 11. And 11 is now bigger than 10, so we don't do what's between do and end. All right, so we exit the loop, and we're done. So that's a loop. Now, I'll just throw a couple variations out at you. If I said something like this, do I equals 1 to 10 without the by statement, the default by step size is 1. So this is just going to output 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could, if I want to count backwards, say by minus 1. So this would count backwards 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then it would stop. There are variations on this. You can do while some condition is true. So do something while I is less than or 10, less than 10. You can also do something until I is equal to some value. So these two statements are equivalent. Do while I is less than or equal to 10, assuming that I only takes integer values. Do until I is equal to 9. You can also, I've found occasional instances where I want to combine all this. Do I equals 1 equal to 10, as long as, for example, x is greater than y. So these are possible. It's pretty rare that you would want to do this, but sometimes you do. So I'll now show you a couple programs that all do exactly the same thing. So let's take a look at the first one. If I just say do I equals 1 to 5, that's going to start I equal to 1, go up to 5, stop, and output those records. So here's the data set that you get. That's what I would do in real life. If I wanted to count from 1 to 5, I would say do I equals 1 to 5. But just to illustrate these until and while loops, let me give you a few other examples. So this chunk of code will create exactly the same data set. So we're going to make a data set example, and we're going to initialize I to 0. Now I'm going to say do this until I equals 5. So what do I want to do? Well, first I'm going to increment I. So let's say I equal to I plus 1. So notice what happens is I was 0, it now becomes 1, and then we're going to output it, and that would be that first record. Then we're going to come back, we're going to check, well, is I equal to 5? No, it's equal to 1. Therefore, we're going to go through this loop again and get set equal to 2. Is it equal to 5? No, so we keep doing this. 3, 4, and then we come in, and once I is equal to 5, it gets outputted, and then we say, well, is I equal to 5? Yes, therefore we're not going to do this anymore, so we exit the loop and you get the same data set. Here's how we would do this with a while statement. So the difference between while and until is that, until is going to check this, at the bottom. While is going to check it at the top. So let's initialize I to 0. We're going to do this as long as I is less than 5. So if we've initialized I to 0, is I less than 5? Yes. So therefore I is going to be I plus 1. Output it. You output the 1. All right. Well, I is now 1. Is I less than 5? Yes. Therefore, we're going to go do this loop again. I gets set to 2, output it, and you get the 2. Do it for 3, 4, and let's see what happens. So now if I is now 4, we increment it to 1. Increment, a value of 1 gives us 5. Now we're going to output it. So we've output the 5, and then we're going to come back up. So is I less than 5? No. I is equal to 5. Therefore, we exit the loop, and we're done. So that's what loops do. Loops are extremely common in any programming language, ranging from BASIC. In BASIC, it's called a for loop. C, it's called a for loop. Python, Perl also has loops, and you will find these 3 types of loops, do, while, and until loops, across a lot of languages. So it's good to know this stuff. Back to functions for a second. SAS will generate random numbers for you with some functions. So the 2 most commonly generated random numbers that I ever use are random numbers from a uniform distribution or a normal distribution. So let's do a little example here. I'm going to say do I equals 1 to 5. X is equal to ran uni. So ran uni means uniform. And then I'm going to specify some value in parentheses. It's called a seed. Random numbers are not truly random. They're more precisely called pseudo-random numbers by computer scientists. And what pseudo-random means is that they appear to be random. You do all sorts of tests for randomness and they'll pass, but they are in fact a well-defined sequence of numbers. Okay, the seed value tells you where you want to start in that sequence. So by specifying this seed, I will always get the same sequence of 5 random numbers when I run this. If you type this in on any platform on SAS, you'll get those same random numbers that I get. So let's print what I get. Here's what I get. I get 5 numbers that are between 0 and 1. Now, actually, hold on. Here are my 5 numbers. That's upstairs is my next example. So you notice these are all between 0 and 1. Now let's do another little example. I'm going to generate 100 random numbers from a normal distribution. So ran_nor gives you something from a normal distribution. Let's print the first 5. Well, here are the first 5 numbers from that distribution. You'd expect these, but 99.7% of them are going to be between -3 and +3, since this is a standard normal distribution. If I run proc univariate, ask for the plot, you're going to see something that looks vaguely normal. The box plot sure looks normal. Just to convince you that this is indeed a normal random variable. Okay, so a few more functions for you with the random number generator and a little illustration of loops and how I can cook up data using these random number generators. Here's an application of these functions. So we're going to get a whole lecture on sampling in a couple weeks, but sometimes you want to sample from a data set. If you have 1,000,000 cases, maybe you don't need to analyze 1,000,000 cases. 100,000 cases might be just fine. So, and it would run faster, use fewer resources. So that's a good idea to sample. So how would you sample down? In SPSS, you do data, select cases, and then you pick off the sample option. In SAS, you're going to do this with a data step. We'll learn another way in a couple weeks, but here's the way we could do it. So ran uni, pick some seed. 1, 2, 3, 4 is my favorite seed. If you do a logical comparison of that random number with, say, 0.5, in essence, that's a coin flip. So half the time, since I'm using 0.5, this expression is going to evaluate to true, and half the time it's going to be false. So how could we draw a 10% sample? I'll use that nonprofit data set that's sitting around in SSCC. So if I set this data set and then I say something like if ran uni less than 0.1, 10% of the time we expect ran uni 1, 2, 3, 4, 5 to be less than 0.1. 90% of the time it's not going to be less than 1. So whenever this random number is less than 0.1, we keep the record. Otherwise, we drop it. So again, this is a binomial distribution, right? With the probability of a yes being 0.1. So we're going to get approximately 10% of the cases. So here's something from the log. So there were 197 cases in nonprofit. Notice that my sample data set only has 17. So why 17? Well, I expect 10%, but this is a binomial, so there's going to be some randomness. I would have expected 20 cases roughly, and I got 17 cases in this sample data set. Another sampling procedure that we did not talk about back in fall, but it was in Siegel, and I'll just mention it to you, is called a systematic sample. So this would be pick every nth record. So if you wanted to do that, so let's say you want to pick every 10th record, how could you do that? Well, this is where the mod function comes in. So let me explain what I'm doing here. So underscore n underscore is a variable that SAS creates for you that indicates the current line number. So if you're in the first line of the data set, underscore n underscore will be 1. Second record, this gets incremented to 2 and so forth. So this statement, if n mod 10 equals 1, means if this record is 1, 11, 21, 31, 41, 51, it's going to keep it. So recall, for example, 10 goes into 21 twice with a remainder of 1, so that's why it's going to keep the 21st record. So if you do this, it's going to keep the 1st, the 11th, the 21st, the 31st, the 41st, all the way up to the 191st record, and you end up with a sample of 20 in this case. So that's how you would draw a systematic sample. Putting my statistical hat on, I would not recommend a systematic sample, and we'll talk about why in a couple weeks, but it's not as... you're better off with a simple random sample or a stratified random sample, as we'll see in a couple weeks.